Hi guys, my name is JJ Khoza. I am back with topic number 6, part 6 of our Algebra Fundamentals. We are now doing part 6. On part 6, I will be demonstrating how to work with fractional expressions, whereby the algebraic expressions are now expressed as fractions. Before, on previous lectures, we did the properties of fractions. I showed you how to work with the fractions, how to add, how to subtract, how to multiply, and how to divide fractions. Those principles are the ones that we are going to utilize now. I hope you can see what I keep telling you, that it is important for us to stack up our information, to stack up our knowledge as we are moving up with the level of mathematics. We started right at the bottom where we spoke about numbers. Now, we're no longer even talking about algebraic expressions, we're talking about algebraic expressions in form of fractions. My second topic on this lecture, it is going to be on exponential expressions. These exponential expressions, they will also require a background, a very strong background of the laws of exponents. I've shown you how to deal with exponents. You must make sure that you understand all my previous lectures, all previous 5, make sure that you understand, so that you can cope well with this part 6 of our Algebra Fundamentals. I'm also going to touch a bit there and there just to remind you on the on the laws of exponents. But right now, I'm going to start with fractional expressions. So the topic for today is fractional expressions. We are doing algebra, so these are fractional algebraic expression. This is what we are talking about. I'm going to show you 3 rules. Mathematics is a study that is full of rules. I always emphasize that. Properties, you have to understand them. The laws, you have to understand them. Without these laws, there is nothing that we can do in mathematics. So even here on fractional algebraic expressions, I'm going to show you 3 rules. So we're talking about rules. Let me write in blue. Rules. The rules. The first one we spoke about a fraction AB multiplying a fraction C over D. While we were doing properties of fractions, we learned that we multiply the numerators, we also multiply the denominators. So let us do that. We're having AC over BD. This is the first one. Number 2. There is a restriction that the numerators, the denominators must never be equal to 0. So I'm just going to make this restriction here. Otherwise, the whole thing becomes undefined. So this is the restriction. B must not be equal to 0. And D must not be equal to 0. Number 2. On number 2, we are dividing fractions. When we were dealing with this topic on the previous lecture, we said we keep one fraction in its original position, and the division sign becomes a multiplication sign, and then we invert, or we just flip over the second fraction. So we are going to have D over C. Now we are back to rule number 1. I'm not going to explain here. You already know what we do. Number 3. We are adding or subtracting fractions. So we have A over B. We add or we subtract C over D. And then we have A, it's plus, or subtract C, depending on what is it that you are doing, over let me start with this one. Where we have a common denominator. Okay, we have a common denominator. So we're going to have A plus or minus C over B. Why? Because B is a common denominator. We also have a restriction. Remember, when we work with fractions and you find that denominators are variables, or even numbers, but especially variables, we are not allowed to have them equal to 0, because it violates the rule. Now I'm going to start with the first example. On this I'm going to do examples, practical examples, because I want to show you how you go about doing this. So I'm going to use examples with numbers and variables. It's not necessarily going to be in general form as you see it here, because I want to make sure that you are able to use this in algebraic expressions. You must not think that when you are working with algebraic expressions, the laws change. The rules of dividing, adding, or multiplying fractions, they remain the same. They remain the same. So, let us do this. I'm going to start with an example whereby we are required to do a multiplication of fractions. Multiplication and division. So I'm not going to write off fractions, because everybody knows who's listening that we're talking about fractions. We need to simplify this. So we have 12 over x multiplied by 2 x squared. Oh, now I'm writing with a bigger over 3. Okay, it looks better. Here we're going to use rule number 1. Rule number 1 here is applicable. Rule number 1. To me, this looks like rule number 1. I want to stress the importance of making sure that you are able to see the rules, to identify the rules, to identify properties of algebra in any given algebraic expression. You must be able to see. So for instance, here we see that this is rule number 1. So it's straightforward, this one. It is equal to 12 times, because we learned that we multiply the numerators. So 12 times 2, we're going to have 24 x squared over 3x. Oh, again, I see something here. I see a variable x and a variable x, of course with different powers or different exponents. Remember that when there is no power written on a variable, the power is actually 1. I've written it in red. Now the step following this one, 3 into 24. What is 3 into 24? It's 8. And then here, what do we do? I now see another rule which we have dealt about in the previous lectures. I see laws of exponents. exponents. Laws of exponents. And if I remember well, it was law number 2, where we divide bases that are the same, and the law says you take the power of the numerator and subtract the power of the denominator. So I'm going to do that. X to the power 2 minus 1, which is 8x. Remember, we have this power 1 here. I'm writing it in red. You don't have to write it. I'm just showing you. What have we learned out of this problem? The first thing is to be able to identify which set of rules are applicable in a given problem. If you can't identify the set of rules that are applicable in a given problem, there is nothing that you can do. You must just make sure. If you miss that part, surely you can't get lucky. You'll just do a wrong thing. Make sure that you are able to see. In this instance, we have seen that there was a rule 1, and which we just discussed, and there was laws of exponents. I want to proceed to another example whereby you are going to see a combination of multiplication of fractions together with a division. So we call this number 1 in red. This is number 2. Doesn't look nice. My pen is writing better now. Okay. We have the second example, which is 3 over 4x multiplied by 2x over 10 divided by 3x over 2. What are we going to do here? What's the first thing that we are supposed to do? This is important to know. The first step. What is it that informs us? Should we start with this and multiply them and end up with dividing? What do we do? Or do we start by working these ones where we need to divide and then we multiply last? We have, it looks like we have 2 options, but there is only one that is correct. This is what you must know all the time. If I remember very well, there is something called BODMAS. Do you remember BODMAS? Everybody knows BODMAS. I'm going to follow this rule. So we have the first term multiplying the second term and dividing by the third term. What is it that comes first between multiplication and division. What comes first? I'm looking at my BODMAS here. I see division comes first and then multiplication comes second. I'm going to follow the rule. So I keep 3 over 4x multiplied by, I encapsulate 2x over 10 divided by 3x over 2. Most of the people make a mistake on this second step to decide what to do first. Because mathematics is a study of logic, we have set of rules that govern the work that we do. You don't do as you please. You follow the rules. We managed to sort this problem out. Make sure that you don't fall into a trap. So, multiply. You remember the laws. I think it was law number. Let me go to the first slide. We are dividing the fractions. When we divide the fractions, we take the other fraction and invert it or turn it upside down. We multiply. The division sign becomes a multiplication sign. So we are doing the same thing here. This sign is going to become a multiplication sign. So I am multiplying by 2 over 3x. And then we have equal to 3 over 4x multiplied by 2x times 2, we have 4x, and 10 times 3x, we have 30x. You proceed, you have 12x over 4 times 30, 120x. The answer is 12 into 120, it's 1 over 10. Remember here, same basis, we're dividing the same basis. When we divide the same basis, we subtract the exponents. So we will have, let me write this, we are going to have x to the power 0, just for you to see, and therefore the answer is 1 over 10. What was the trick here? BODMAS. You must know your BODMAS. You must know what to do first. That's the important thing that you must know. I think this is clear. The fractions of algebraic expressions, they can come in any form. You just apply these rules. And the rules are captured from lecture number 1 up to lecture number 5. Right now, we are actually applying those rules. We are applying them. That is why I started in part 1, to give you ability to deal with these type of things. Let us go to number 2, or slide number 3. On slide number 3, we are going to look at the addition and subtraction of fractions of algebraic expressions. So here we're doing addition and subtraction of fractions, of course, of algebraic expressions. Here there's something that we've got to look for, an LCM, a lowest common denominator. We need to find the lowest common denominator so that we can be able to move forward. And you must be able to find a lowest common denominator. So I want to show you how to find the lowest common denominator. It's important to be able to find the lowest common denominator. So we are talking about LCD and LCM. Which is the lowest common multiple. I will start with the LCD. The LCD, let us say we have the following: 1 over 2 and 3 over x. And 6 over, let me write this 6 properly, and 6 over 3x squared. How do we find the lowest common denominator? So the lowest common denominator here, we are going to look for a number that will allow us to divide these denominators. Also the variable that will accommodate our problem here. So the LCD is 6x squared. We will be able to work with 6x squared because 6x squared, here you are going to divide, you are going to divide by 2 for the first term. For the second term you'll divide by x. For the third term you divide by 3x. So it accommodates all conditions. What about the LCM? Let us say you have, let me make this thicker. Let us say you have a 2, a 3 and a 4. What is the LCM here? The lowest common multiple. The lowest. How do we find the lowest common multiple? It's the number when you multiply, like we have 2, 3 and 4. When you multiply 2 and 4 you get 8. When you multiply 3 and 4 you get 12. Are we going to use 8 or 12? Or we are going to use 4? How do we decide? The number that we are going to use is the number that must accommodate all the three numbers that we have here. So I think the answer is 12. 3 multiplied by 4 is 12. So these are the answers. Now we know. Let me do an example. We have 2x over 3 plus 5 over 4 plus 3x over 12. What is the LCD here? We said an LCD is the lowest common denominator. And the LCD must enable us to do our operation, meaning that it must be able to divide 12, it must be able to divide 4, to be divided by 4, it must be able to be divided by a 3. Which is the lowest number that can enable us to do that? Well, it looks like 12. The answer is 12. LCD. So what are we going to do with the LCD? What do we do? Right? I'm going to use two colors. So we bring back our 2x, and on the side here I'm going to do calculations to show you where do I get the things that I do. So 12 divided by a 3 is equal to 4. I'm going to take this 4 and multiply by it, because and multiply by it here, and then also here. My intention is to make all the denominators the same. Once the denominators are the same, then it's simple. I will come again. 12 divided by 4, the answer is 3. I take this 3, I multiply here. Lastly, 12 divided by 12, the answer is 1. I take this 1, I multiply it here. Good. Now we have 2 times 4, it's 8x over 12, plus 5 times 3, 15 over 12, 3x over 12. Remember the rule number 3 in the beginning of this lecture. It talks about similar denominators. So we're going to add this and have 11x plus 15 over 12. This is the answer. I hope this was straightforward. Now, I want to show you something different. Or you think this is enough? There's something that I want to show you, just one last trick. It involves the change of sign. That's the thing that I want to show you. Otherwise, you are going to use these rules. Let us deal with the change of sign. Examples involving the change of sign. I'm just going to write change of sign. Change of sign. And here, I'm going to demonstrate 3 things which you need to understand. The rest is what we've been doing over and over and over again. Let us say you have, in case number 1, you have a negative x over y. What does this mean? It means maybe your x was negative and your y was positive. Or your x was positive but your y was negative. This is what it means. But generally, you'd put your negative sign here. Case number 2. I think this one is interesting. You have x, it always comes. So I'm just going to explain this principle only. I'm not going to solve any problem here. Otherwise, we're gonna do the same thing all over and over and over again, over and over again. So I'm doing this. We had a negative here, a negative sign. What does this tell us? It means we had this case is a possibility where our denominator was negative, or we had this case where our numerator was negative and the denominator positive. And in this case, when you simplify, we are going to have, remember, now I see something, a distributive property. You remember, we multiply and we multiply. A distributive property. You remember when we did properties of real numbers? I think it was lecture number 2, if I'm not mistaken. So now it's important. That is why I say you have to have your toolkit. These laws are toolkits. There is no creativity here. You just use the tools. In place of a spanner, you use a spanner. You're not allowed to use a screwdriver. Okay. So I'm going to have a negative x, because negative times positive is negative. Remember when we dealt with properties of negatives? Now that rule comes back. Negative multiplied by negative. Properties of negatives. It taught us that negative times a negative, we get a positive. All over y. Alright? Thirdly, this one always trouble every learner. Most of the learners, students, make mistakes. Even if you know here, sometimes you make a mistake. So it's important to pay attention and be careful all the time. Let me just make this example. You see, because these cases come whereby you need to be able to manipulate the elements in the algebraic expressions to favor a certain situation. Sometimes that you will find that you need to make certain things look similar. So here we can have this case whereby I say y minus x all squared. These two expressions are equal. Why am I saying that these two expressions are equal? I'm saying this because we had x minus y all squared, which then I swapped around the positions of x and y, and this is what I did. I had a negative, so we come back to this one. You see what we did here? I have a negative. In fact, I had a negative x. So I had a negative y. Here you look at this. A negative y. Okay. And there was a positive x. This is what we had. Right. But if you put it in brackets, you take out now. Let us take out a common factor, or let us divide through. We take out a common factor of negative 1. We encapsulate again. We encapsulate. This positive becomes negative, because negative 1 divided by a positive, it becomes negative. So this is what we are having. Equal to, we have a square here, so it means we are going to have x multiplied by x, and then we will end up with a positive number here because there is negative 1. We are going to end up with y minus x all squared. So x minus y all squared is equal, x minus y all squared is equal to y minus x all squared. These are not easy, these ones. The third part, not easy. Not easy at all. Do you want a demonstration? Well, maybe I can just do one. I'm going to take something simple. So we have 3. We have 3 into x minus 2 over x minus 3 divided by 2 into 2 subtract x over 3 subtract x. I think you can see we have x minus 2, we have 2 minus x. We have x minus 3, we have 3 minus x. So this is important for you to identify. And how do you turn this around? I said you will need to learn these rules, these 3 rules, in order for you to be able to turn things around to favor a particular situation. So here I will keep this 3 into x minus 2, I keep it as it is, over x minus 3. I like it, I'll keep it like this. And then multiplied by. Now, we know that things are going to change. We take the other fraction, we turn it upside down, or we just invert it, we simply invert it. Now, we are going to have three subtract x over 2 into 2 minus x. So now you look at x minus 2 and 2 minus x, and we also look at 3 minus x and x minus 3. We see a problem. We have to manipulate this in order for us to be able to have a favorable position. Otherwise, this thing is gonna get too dirty. Before we do the multiplication, let us solve this. What are we going to have? We have a negative x, a negative x, and a positive 3. This x is negative, this 3 is positive. I hope you can see. Over 2. This x is negative. We have a negative x here. I'm doing this deliberately. And we have a positive 2. A positive 2. Okay? X minus 2 over x minus 3 multiplied by. Now, we have to encapsulate this, take out common factor of negative 1. So, negative into negative divided by negative x, we have positive x. Negative 3, positive 3 divided by negative 1 is negative 3. Also, we take out a common factor here of negative 1. We have 2. So we are simply going to multiply negative 1 in positive 2. We get negative 2. And we apply the same principle as we did with our numerator. X is then now going to be positive, and 2 is now going to be negative. Then it looks good. When you look at this, and that goes. This and that goes. This is what I wanted to show you. So we have negative 1 here. The answer is negative 3 over negative 2, which is positive 3 over 2. These are not easy. We can simplify, but they are not easy. I think you are now in the position of working with the fractional expressions. So now we come to the end of the lecture. It was quite long. I did not anticipate more than 30 minutes just with fractions. The next topic is going to be exponential expressions.